The Pacific Science Center's Rotary Discovery Lab is returning a favor today by arranging for our main speaker. Dr. Jonathan Overpeck is there lecturing on megadroughts in the western United States. Every day we wonder about global warming, climate change. To help us understand, we're fortunate to hear from Dr. Overpeck. He's a director of the Institute for the Study of Planet Earth at the University of Arizona. It's professor of geosciences and a professor of atmospheric sciences. His specialties include climate dynamics and climate and ecosystem interaction. He shared a 2007 Nobel Peace Prize for his role as a coordinating lead author for the UN Intergovernmental Panel on Climate Change. Please welcome Dr. Jonathan Overpeck, speaking on global climate change and the U.S.
Well, thanks, John, and I also want to thank the Pacific Science Center for making it possible to come here in collaboration with the Joint Institute for the Study of Atmosphere and Oceans at the University of Washington. You have in the University of Washington literally the mecca of climate science in the United States, and I urge you all to learn more about what's going on with our climate with your own colleagues here in Seattle. But it's a real honor for me to come, and I'm looking forward to the presentation tonight. I gave one last night as well. And what I want to do today, if I can, and I see I don't have a clock in front of me, is leave enough time for some questions. I think that's often just as important as any presentation, is to give people in the audience a chance to ask some questions that bug in them about climate change. Well, what about climate change? I like to actually call it global warming because that's literally what's happening. Why is it that all three senators that are in the race for president are on the record that we must do something as a country, as a world, about climate change, when at the same time there's a small, very small, but well-funded, organized effort to confuse the public or to at least say, you know, global warming is not an issue to worry about? Well, I was lucky to be involved for the last 7 years with this large UN World Meteorological Organization report on climate change, the fourth assessment. There will be a fifth assessment, we hope. And the idea is that we assess in this, the scientific community that studies climate, we study what's going on in the climate system from the viewpoint of the scientist who studies science. Well, so we're assessing the literature that is published in peer-reviewed journals. And what I wanted to convey today is a little about what we know about climate change, global warming, and what we don't know. We know, for example, that greenhouse gases, carbon dioxide, methane, nitrous oxide, a number of others that act to warm the lower atmosphere are going through the roof, and that they're higher than any time in the last 650,000 years, far above any natural limits. We know from the composition of these gases, the chemical composition, that they're produced predominantly by fossil fuel burning. There are other sources as well. We know that the Earth is warming. We know that it's global warming because it's warming everywhere around the globe. There are a few places that aren't warming as dramatically. For example, the southeast United States and the North Atlantic. There are other places where we don't have great records going back far enough to say how long this warming has been going on. But basically, we now believe that the temperature of the Earth over the last 50 years is unprecedented in at least 1,000 or more years. And it's because of these greenhouse gases that are going in the atmosphere. And we're now 90% sure, we being the scientific community, 90% sure that humans have caused the bulk of the warming. We also have this little pin on I was just given by a visiting scientist here at the University of Wisconsin who is the leader of our IPCC effort, Susan Solomon. And the little pin she created for the Nobel Prize ceremony, and she was nice enough to at least give me the little pin, because everyone couldn't go, obviously, to Stockholm. It says global warming is unequivocal. The reason we say it's unequivocal is not just because the whole Earth is warming, the atmosphere, but we're also seeing a lot of other signs that are consistent with this warming. We're seeing that the oceans are warming, and not just at the surface, but well down into the ocean. So many of you might have seen the article in today's newspaper, which I heard about, talking about the new array of floats that we're putting over the world's ocean, basically little robots that go up and down in the ocean. Every time they come up to the surface, they telemeter the information about what's under the ocean, temperature, salinity, and other properties. It goes back into a computer, and we can actually monitor the whole pulse of the world's ocean now. And yeah, there are ups and downs from year to year in the ocean temperatures and the air, just as in the air temperatures, even here in Seattle. Why is it so cold this spring, for example, this week? Well, this is variability against a long trend in these other variables. Global temperature is inexorably going up. In the western United States, it's warming the most. In parts of the west, down where I live, are warming the most of all of the United States outside of Alaska. We've gone up about 2 degrees Fahrenheit in the last 30 years. That doesn't sound like a lot, but it's having some profound effects, which I'm going to talk about in a second. We're also seeing big changes in the cryosphere, the ice on the planet. You've heard about the sea ice in the Arctic Ocean. It's retreating in summer far more quickly than we thought possible year after year. We're also seeing retreat of glaciers just about everywhere in the world. And yeah, you can find a glacier here or there that isn't retreating, but almost all of the glaciers around the world are retreating. We're actually seeing changes in both of the world's big ice sheets that are really scary because they're negative. And these ice sheets the heights of these ice sheets are starting to go down, and as they do that, they're contributing, of course, to sea level rise. Sea level rise, though, is not being driven predominantly by the glaciers at this point. It's being driven by expansion of the ocean. As it gets warmer, it takes up more volume and it laps up on the shores. And we know how much the sea level is going up, and we can calculate how much the ocean is warming, and they give the same answers. In other words, we do really understand all of these consistent messages we're getting from Mother Nature that makes us say, and there are many more that I'm not mentioning here, that the evidence for global warming is unequivocal. Interestingly enough, we used that term in our last plenary session in Paris at the UN UNESCO Center there with diplomats from 113 nations of the world that make up the Intergovernmental Panel on Climate Change. And the diplomats' role with the scientists, just 30 of us who were representing the 600 who are involved in this report, had to agree on the actual line-by-line wording of this report for their policymakers, their presidents, their premiers, their environment ministers. And they had a lot of trouble with some words that we proposed, the scientists, but one word they did not have any trouble with was unequivocal. So it's a very robust finding. But where's the uncertainty with global warming? It turns out that there is a good deal of uncertainty, and it all has to do with what's going to happen in the future. What are the big unknowns? How much more greenhouse gas are we going to put up in the atmosphere? We control that. That's the good news. We control how much greenhouse gas we put up, and therefore we control how much more climate change we're likely to get. The other big source of uncertainty, which you've heard about, no doubt, is that we use these climate models. We're forced to use climate models to predict into the future. These models we think now are pretty darn good. They can capture the interactions between the atmosphere, the oceans, many parts of the cryosphere, the clouds. Most of these processes in the climate system that are important are represented one way or another in these models. But of course we don't understand the physics of the climate system perfectly, just as we don't understand most things in life perfectly. So the models, whether they're from the UK or they're from Japan or one of the premier models from the United States, they all don't give exactly the same answers. So we get a range of possible climate change, whether it's temperature, precipitation, storminess, whatever, depending on which models we look at, and depending on, of course, what scenarios of greenhouse gas emissions we're considering. Those are the big uncertainties. So what do we know about the future? We know with a good deal of confidence, just as the Earth has been warming, is that it'll continue to warm. Temperatures by the end of this century in the Seattle area, 10 degrees warmer than today, are a good possibility. All right? Seattle's not one of the places that I would characterize as a big loser with climate change. Big losers, you're lucky, all right? And I want to focus a little more on other parts of the United States that I think really have good reason to pay a lot of attention, although I don't want to convince you that you don't. Because as we all know, we're interconnected, right? Global economy. But when a big disaster strikes New Orleans, of course, pays biggest and hardest with lives and property and dreams lost. But our whole country then has to pay for a lot of what then happens thereafter. One of the biggest threats with global warming is going to be sea level rise. And what we're seeing now is relatively slow sea level rise. But what we're doing is we're warming the Earth up to a point, and I do my own research on this, where not only will we have an expansion of the ocean that can cause meters of sea level rise, meters I'm talking about, means 1 meter is 3 feet, right? So many feet of sea level rise can just come from the expansion of the ocean that's likely to occur in the future. In addition to that, though, these changes that are occurring in the ice sheets of Antarctica and Greenland are very scary to scientists, in part because we don't understand all the processes, but in part if you take a geologic perspective like I have in my own research, you see that the last time the Arctic was 3 to 4 degrees warmer than today, Celsius. So we'll be reaching that maybe by the middle of the century if we keep the pedal to the metal on our greenhouse gas emissions. The last time that happened, we got 4 to 6 meters of sea level rise. That's 20 feet. Back then, the Florida Keys were a reef underwater. And if you drive out on the Florida Keys now, you're driving out on fossil coral rock. And that was live coral underwater 125,000 years ago. That warming was caused by a change in the Earth's orbit, but it tells you that just a little warming can cause a lot of ice sheet transformation of ice on land into sea level rise in the ocean. So that's a biggie. Another real biggie that we have to concern ourselves with, particularly for those of our friends and colleagues and just fellow citizens who live on the coast, is hurricanes. And there's been a lot in the news on this. But one thing the scientific community seems to be content with a good, strong consensus is that we're likely to see, likely means we don't know with perfect confidence, but with about 66% confidence, which is better than a lot of other things in life, that we're likely to get more intense hurricanes, and bigger hurricanes, and more rain. Not more hurricanes in general, but more of the big ones, like Katrina. And Mother Nature is giving us, I think, a really good wake-up call. And it's very unfortunate we have these hurricanes hitting places like New Orleans. But nonetheless, if you look at the record of hurricanes in the Atlantic, they have been getting more intense. When I was in graduate school 20 years ago, these are the things that were predicted then by some of these outspoken scientists. And they are all coming to pass, it seems. It's kind of scary. Okay, but what about sea level rise? I think we could have a big hurricane impact any time, just like another Katrina. The odds of Katrina repeating go up and up as we go in the future. It's exacerbated by rising sea level, of course. The biggest sea level change, though, might not come for centuries, but we will commit ourselves, well, our future generation, our children, to this bigger sea level change is what we're really talking about. What about climate change that could really affect us and our economy right now? Besides a major hurricane impact, it's really what's going on in the West. And when it rains too much up here, come on down and visit us in the Southwest, where I tell you it's quite sunny. In fact, it's a little too sunny. We've been in a drought since 1999, and it's been dry. We're seeing major transformations of our forests because we're getting dieback of whole thousands of square miles of trees. We're also getting big changes in our water resources. Lake Mead and Powell on the Colorado River. These are the lakes that feed much of the Southwest. Our water that we so dearly need to operate were full 8 years ago, are now half full, will never fill up again, unlikely. And we anticipate all these models that give you this range of how the river flow will change in the future. They're all negative. They don't say how, they disagree in how negative, but they're all negative. The thing that makes it scary to me is that all this is happening right now. We're getting increased temperatures, we're getting reduced snowpack, even in your mountains in the spring. This is a snowpack we need for our water infrastructure. And we're getting reduced as a result of water in our rivers that we use for all sorts of things. Up here you use it for agriculture, hydropower, the fish, etc. Down in Arizona, it's really literally our lifeblood. We're seeing all those things reduce and go down. That is exactly what the models say should be happening. What's really eerie, because the models, we have a lot of confidence in temperature going up, precipitation, rainfall, snowfall is a lot harder to predict into the future, but it's really eerie that all the models, save one, say that the western United States should be becoming drier in winter, and that is what's happening. Storm tracks are moving further north, and we're getting this aridification of the Southwest, and frankly, we're very worried about this because we are the fastest growing part of the country, and our economy depends on that growth. So these are serious problems, and I think the message is we have to do two things. One is we have to learn to adapt to climate change as a nation. We have to, in our business planning, in our resource planning, in our everything we do, teaching children in school, we have to put climate change into the equation because it's very much a reality now. It's not just a future thing. And if we make more effective decisions, of course, we can deal with climate change effectively. But there are also going to be these large climate changes, these more dangerous changes that we will find probably as a nation and as a humankind that are just unacceptable. Melting of ice sheets is one, aridification of the West, but also of other arid parts of the world that are going and already starting to get drier. So that's where this climate change mitigation comes in. That's where it comes in. Let's reduce the greenhouse gases in the atmosphere. We have, of course, many ideas on how to do that, from conservation to solar to wind to coal with carbon sequestration. There are many different ways we can do this. And this is why all three senators running for president at this point are advocating that we do something about it. And I think next year we'll all, as a country, really start to focus attention not just on debating it, but actually doing it. And with that, I'd just as soon stop, and if there are any time left for questions, to take some questions, please. And I think there's a microphone.
Ask the questions on the mic so you don't have to repeat them.
Okay.
Doctor, thank you very much for your remarks today and for mentioning the Seattle Times article this morning, which talked about the 3,000 robotic monitors in all the oceans of the world. Toward the end of that very long article, it said the most recent 5-year results of all those monitors was that the ocean temperatures had not risen in those 5 years. How does that jibe with all the other evidence that we see?
Yeah, this is a new technology, and it was a very important thing that we've all been fighting for. Tom Ackerman, professor here and leading climate scientist at the University of Washington, and others, we've been fighting to deploy these, get the money to get these out in the ocean for some time, but they're new. And so I think there are two things going on, and we're not sure exactly what's going on. For one, before I get to what's going on with these Argo floats, is we have records going back much farther into the last century from depth in the ocean. You know, we've been going to sea for a long time. We've just never had these robots all over the whole ocean. And it's clear that there's a trend towards warming of the ocean, not just at the surface, which of course we can easily measure with buoys, ships, and satellites, but at depth. And that warming is going down over 1,000 meters, 3,000 feet into the ocean. What we see, though, on this record with this trend, just like our atmospheric temperature trend, is you see year-to-year variations. And so we're not sure with these floats is what we're seeing is a period of low change, which we've seen many times over the last 100 years as things have warmed, or if it's something to do with the calibration of these instruments. They're so new. What these things do is they have sensors in them, and they're able that measure temperature, salinity, and other properties. They go down in the ocean, and then they come back up to the surface, and then they send their information via satellite back to central processing. And we're still working on to make sure that they're calibrated so that the measurement, and we're talking very small amounts of temperature and salinity change every given year to year. So are these instruments actually recording reality, or is there some bias that we don't quite understand? And it's the same deal with satellites. You know, when you have a thermometer, man, that's like, you know, there it is. You know how it works. But when you're using a satellite or you're using one of these fancy robotic devices in the ocean, there's a lot of technology that goes into them. And so we don't really know. And there are scientists here at in Tom's Institute that are spending a lot of time trying to work this out, I believe. So you could ask him about more information.
Our politicians, as have you, point to solar and wind, and whereas it seems that those will be partial solutions, nuclear is, although it's sort of vaguely mentioned, is not often really pressed. Do you think a national program that would point to 50 or 60% of our electrical energy being nuclear in the next 15 years would make sense?
I would advocate, as I think I'm not actually sure if your Congressman Inslee has said this in his book, Apollo's Fire, which I've started to read. It's pretty good because it talks about solutions. The point is there's no one silver bullet to deal with this problem. There has to be, we need to basically look at all the possible solutions. In Arizona, I think there's a huge land buy-up going on right now, and our partners in the solar industry think that by 2012 we'll have economically viable reason to deploy solar across the state in northern Mexico. It will not, as you said, solve the world's problem, but it'll be a very important step in the right direction. And you'll have a lot of others. You brought up nuclear. Nuclear is an interesting one. I don't think we're going to need it if we deploy and exploit all the other options that are available. But nonetheless, we shouldn't leave it unconsidered. The problem with nuclear, as I understand it right now, there's several-fold. One is that not a lot of people want to have a nuclear power plant in their backyard. Maybe people can get over that. Second is, as a nation, we don't have a place to put radioactive waste, high-level radioactive waste at this time. My own understanding, I've actually been a consultant for Nevada on the Yucca Mountain site, and I've been evaluating from a climate point of view. I don't think climate's the big problem with that site. I think the fact that it's ringed by recent volcanic extrusions, let's call it small volcanoes, it's ringed by small volcanoes that are all just a couple million years or less old. I think that's the big problem. In other words, we could easily put our waste there and have it blown right through by a volcano, small volcano. It's not like Mount Rainier, but these things could nonetheless completely release that stuff to the environment. So I don't think it's ever going to happen. The third problem, and we need to find a solution, and I'm all up for, as a nation, let's find a place to put radioactive waste because we have a lot of it, and we need to get rid of it, let alone create more. Another issue that the physicists like to point out is that we don't have enough uranium for our traditional reactors. We need to go with breeder reactors in order to do that. We need to reprocess the fuel in order to have enough fuel for the big industry that you're envisioning. And couple that with the fact that whatever solutions we find, if we do this right in the United States, it's going to be a huge economic driver if we're in the driver's seat, that is. And right now, Japan, China, and Europe are more in the driver's seat than we are. But, of course, the United States has a lot of cleverness in it. If we're going to be in the driver's seat on any of these issues, they're going to have to be deployed globally. And breeder reactors and fuel reprocessing globally, what does that translate to? It means a hell of a lot of bomb-grade plutonium around the world. And we have to decide as a society whether we think that's a safe thing to do.
Yes, in the popular press, there's been stories about the Gulf Stream and the possible effect of climate change on the Gulf Stream. What do the scientists think about that now?
Yeah, there was the movie Day After Tomorrow, I always like to mention, because it starred Dennis Quaid as a paleoclimatologist. I'm a paleoclimatologist, and I thought that was really cool. Nonetheless, that was a really serious work of science fiction, as many of our best movies are. And scientists are much less concerned about that issue now than even they were when the movie came out. We first discovered in the geologic record, particularly during the ice ages, there were these whopping big changes in the North Atlantic circulation. And that's basically the currents. Somehow, more sunlight comes in at the equator of the Earth, and somehow that has to get redistributed around the Earth. We think about half gets redistributed by the atmosphere. Hurricanes play a big role. And half gets redistributed by these ocean currents. And in the Atlantic, it's the Gulf Stream, and the North Atlantic Drift takes all this heat, keeps North Atlantic on the European side a lot warmer than on our side. It's possible that that could slow down appreciably, and that's one reason why one of the areas that is cooling right now is in the North Atlantic, we think, although it's difficult to tell. But nonetheless, in the future, most scientists think what will happen with the North Atlantic is you will get a slowdown of that circulation, and it will mean less warming, not cooling, but less warming over the North Atlantic region. We are very confident that we're not talking about it triggering another ice age or anything like that.
you and your colleagues think about the opposite side's arguments that the Earth goes through cyclical change and climate anyway, and this would be happening anyway, et cetera, et cetera?
Yeah, well, Dennis Quaid wasn't a real paleoclimatologist, but I was. I am. And I can tell you I spent all my career working on that topic, because we're looking at climate change over centuries, millennia, to tens of thousands or even millions of years. And we are looking at the climate system for many reasons. We want to understand how has climate changed in the past and why. And right now, we said very clearly in the report, the UN report, that we know of no known natural cycle that could be causing the change that's occurring now. There is no evidence for any natural cycle that could causing this warming. That is a pretty unequivocal statement. There could still be something out there, but there are a lot of scientists in my field been looking for decades at this topic, and we haven't found anything yet. What you see going on is a very, I believe, fairly well-funded disinformation campaign. Scientists who are not climatologists or even climate scientists are digging up old literature that's now outdated and saying, hey, here's a paper that said there was a cycle, and this cycle, if you map it out, should be causing warming now. That's not how science works. Those papers that talk about these things have not proven to be good science, and they haven't been able to replicate it. And that's what science is all about. You make a hypothesis, you test the hypothesis. The people that were making those hypotheses, we're still trying to test them, but we haven't found any, all the evidence rejects those hypotheses.
Thank you. Thank you very much for coming to do that. Wow. Now I think I might be able to read the next article on global change, climate change, warming, and maybe understand it. Thank you very much, Jonathan, Dr. Jonathan Overpeck. You're going to, as you mentioned, you're going to be telling people more about this tonight at 7:30, IMAX Theater at the Pacific Science Center. Students are admitted free, so if you've got somebody like that, get them down there to take a look at it. Next week, we're back here again at the Convention Center to hear, this is the second time you heard this name today, Jennifer Sizemore, Vice President and Editor-in-Chief of award-winning MSNBC.com. Haven't you wondered why digital is the new media mainstream? Jennifer will tell us. And our short program, you'll get a better understanding about early learning. So thanks, everybody, for joining me in Rotary Fellowship and Service. We're adjourned.
Seattle Rotary Online is made possible in part by a grant from First Choice Health, working with the Washington Health Information Collaborative to use technology to bring better health care to patients throughout the Pacific Northwest. First Choice Health.